Okay, LRU Cache. This was a fun problem. It's a weird one, but it's a fun one because, at least for me who has not done too many leak codes, this was an exercise in doing object-oriented programming in Python. So, essentially the LRU cache, don't look first on this link, I'm just going to explain it. Whenever you have numbers and you're adding them to LRU cache, you have the operations get, put. So get gets an item, put puts an item in. So I want to start with put. We have the capacity in our LRU, and it's basically saying we're only going to keep, let's say, 3 numbers, 3 items, and we're going to discard them if they're not the 3 most recently used items. So what does that mean? Let's say we put 1. 1 goes here. Then we put 2. 1 is not the most recent item. 1 is the second most recent item. So we put 2 and put 1. And we put 3. This becomes 3, 2, 1. Then we put 4. 4, 3, 2, and 1 gets discarded. 1 gets evicted. Now, what happens if we want to access one of the items? We want to access 2. This is the least recently used. However, since we're accessing it, it becomes the most recently used. 2, 4, 3. Now if we access 4, we get 4, it goes here, 2 becomes second most recently used. You get the idea. So, how do we achieve this in O of 1 time? I'm just going to jump right into it. What I immediately thought of was some sort of linked list, because we want to preserve the order structure, like this and this. These should all be pointing to each other. They should not be contiguously next to each other in memory, because if you want to rearrange the order of everything, then you're cooked. You need to reallocate. That's not O of 1, it's O of n. If you use a linked list, you can simply move stuff around just by adjusting the pointers. But how do you get from a linked list in O of 1 time? How do you traverse it? Because as you know, the worst case scenario for linked list is that something's at the tail and you traverse the entire thing that's O of n. Well, there's actually a second component. There's a dictionary that keeps track of keys, because we're given keys. And it has keys associated not to values, but to the nodes themselves. So that allows us to, in O of 1 time, get the node itself. That's the main idea. And then the steps to implement this problem are, first, you need to figure out your node structure. I went down a very bad rabbit hole of not creating a wrapper class for my nodes. And so what that meant was I did not have a DLL. I was just implementing both the remove, add, slash, rearrange functions. All of that was implemented inside my LRU cache when it shouldn't have been. Additionally, I forgot to put the key in the node, so that was not a big fix, but that's something to consider. So once you get those working, make sure you have them working. Make sure you don't forget to like add a pointer or something. Like for example, I forgot to set the previous of the node that we're adding to the start. I forgot to set its backwards pointer to the head, which is a sentinel of the list. Oh yeah, and by the way, this is a doubly linked list, because since we would want the most recently and least recently used in order to just access for stuff, we want to be able to We want to be able to remove from the tail and add to the head, because we're taking the least recently used and adding it to the most recently used for the get function. And yeah, so when you have those done, the initialization is pretty straightforward. Add first, sorry, yeah. Sorry. The initialization pretty straightforward. Get and put, which one's bigger? I thought get was going to be bigger, but actually put ended up being longer. Oh yeah, and there's one more thing you need to consider. I think these are all like just implementation details. However, you should consider the actual eviction step. Make sure you have something that removes items, because I was not removing things, and that meant my test case failed. So, just as a final thing, I'm going to show the entire code and you can look at it. But yeah, that's it.